anyway, no. Jokes aside, it's great to have Tim here today, and the first session was great. If you're able to be here for that one, and if not, I know they're all being recorded, so you can maybe check that out later on as well. A little bit about Tim. He works for Stand to Reason. He's worked there since 2015. It's an apologetics ministry, helping Christians and seekers to understand the truth of God's word and who Jesus is, through reason and through humor as well. He is also the author of his own YouTube channel called Red Pen Logic, and if you haven't had a chance to check that out, I'd highly recommend it. Just little couple-minute videos, just basically debunking different claims against Christianity, and it's very accessible for lots of people. His wife Stacy and his 3 girls live in Newmarket, so he's kind of a local guy. We taught at the same school, actually, not at the same time, so he's familiar with the Christian with education system, and he's a teacher as well. So he's also kind of more related to the first session this morning. He's on the topic was deconstructing Christianity. He's currently authoring, writing a book that's going to come out by that same title, Deconstructing Christianity, coming out in January. So if you're interested in learning more about that, you have to wait a couple months. But it's going to be a great resource, I'm sure. So if we could just warmly welcome Tim with a round of applause.
We were both at People's Christian Academy, but at different times, right? I had just left. Andrew was there to fill the void. Okay, so where do we start? Well, this is a session on are science and faith compatible, I think is what we called it. And so here's the question. Science is compatible, or the statement, science is compatible with faith in God, true, false, or not sure. And a lot of people say, no, these are totally separate arenas, right? Faith, in fact, faith might even be the opposite of reason and science. But here's the thing: if we're going to answer this question, get the red pen out here for a second. If you're gonna answer or address this statement, we need to understand what is science. Okay, we got to understand what is faith and who is God. Who is the God that we're talking about? And all those actually are really important questions to ask in answering this particular question. There's an article in the New Yorker a few years ago, and it was authored by Lawrence Krauss. Now, Lawrence Krauss is a very famous theoretical physicist, okay, and he's an atheist. Pretty outspoken about his atheism too. And there's still some seats if those guys were looking into. There's still a couple seats. And the title caught my attention. All scientists should be militant atheists. And here's some lines from the article. It says, this commitment to open questioning is deeply tied to the fact that science is an atheistic enterprise. Well, that was news to me. Okay. Science is an atheistic enterprise. It goes on to say, it's ironic, really, that so many people are fixated on the relationship between science and religion, and by religion he means faith in God, that kind of thing. He says basically there isn't one. There's no relationship between the two. And then finally he says in the article, it's inevitable that it, speaking of science, draws people away from religion or God. Now, what's interesting about this particular article in the New Yorker is that this is actually the exact opposite of my own personal experience. So I graduated from York University. I went there and got a degree in physics and math, okay? And it was actually while I was doing my degree in physics with all my, physics and science friends. We typically hung out in the science library called the Stacy Library. It's actually where I met my wife. Okay. And I might tell you about that story in a little bit. It was in that context where I was getting my faith challenged, and I'll be honest, my faith was not very deep, okay? It was pretty shallow at that point. Really, I was just kind of going through the motions, going to church because that's what we always did. But then I was being challenged, and I started looking into the question of God's existence. And what I found was, man, there's a lot of really good science to back up belief in God, and in fact, Christianity. So what I want to do is spend the next few minutes looking at science, faith, and seeing if they're compatible. Now, you need to understand that over time, words have a tendency of changing their meanings, okay? Like some words have come to mean the exact opposite of what they used to mean. So take the word awful, okay? A century ago, the word awful meant to be full of awe. But I didn't wake up this morning and turn to my wife and say, honey, you look awful. That'd be a bad idea, right? And that's because words have changed their meanings. The word today means like extremely unpleasant or distasteful, like Star Wars: The Last Jedi, right? That might be more controversial topic of science and faith. But I actually think, just like the word awful, the word faith has changed its meaning, okay? It's changed its meaning. And just to give you a sense of what it means today, I want to show you a clip from a video. In fact, Brett Kunkel shared this video last night, okay? It's actually from Miracle on 34th Street. You guys seen Miracle on 34th Street? Okay, now, I know there's one that we watch every year. It's like the colorized version. It's more a recent version, but there's actually like the black and white version. And I want you to see in this older black and white version of Miracle on 34th Street how the mom describes or defines faith. Here's what she says.
Couldn't get it because you're not Santa Claus, that's why. You're just a nice old man with whiskers, like my mother said, and I shouldn't have believed you.
I was wrong when I told you that, Susie. You must believe in Mr. Kringle and keep right on doing it. You must have faith in him.
But he didn't get me that. That doesn't make sense, Mommy.
Faith is believing in things when common sense tells you not to.
Huh?
That was Brett Kunkel did that. That's pretty fun. So you notice how she defines faith. Faith is believing in things when common sense tells you not to. And this is actually kind of the working definition that most people have in their minds when they hear the word faith. Okay, so here's a guy like Peter Boghossian. He's written a book. He's an atheist. And he wrote a book called A Manual for Creating Atheists. So it's like, if you want to help convert people or maybe deconvert people from Christianity, like talk them out of their faith, then get this book called A Manual for Creating Atheists. And here's what he says in the book. Faith is the word one uses when one does not have enough evidence to justify holding a belief, but when one just goes ahead and believes anyways. In fact, in the same page of the book, he says, faith is belief without evidence. Faith is belief without evidence. Okay, so on this view, faith and science are going to be completely at odds. Okay, like faith is when you have no evidence. So it's more like wishful thinking. And that's why people use like the words blind in front of faith, right? Blind faith or leap of faith. On the other end of the spectrum, you have science. That's not wishful thinking, that's like rational thinking, because that's when you have good evidence. So you got evidence, you don't have faith, you have something else. Okay, so you can see on this definition, they're at odds. But I actually don't think that's the right definition of faith. At least not the way the Bible uses it, okay? For example, I like how Sean McDowell describes it. He says, faith is not belief in spite of the evidence. It's belief in light of the evidence. Not in spite of the evidence, but it's belief in light of the evidence. Or maybe you've heard of John Lennox. If you want like the best resources on the science and faith question, you want to read John Lennox. The guy has more letters after his name than in his name. Okay? Like, I think he has maybe 2 or 3 doctorates, okay? Like Oxford professor, mathematician, and he says, faith is a response to evidence, not rejoicing in the absence of it. Okay? It's when you respond to evidence. Now, where is he getting this from? How did he come up with this idea? Well, I actually think this is what the Bible teaches. Okay? So, for example, we could just look at the New Testament for a second. And I'll just walk you through one passage. We could go to a number. But in the Gospel of John, John tells us why he wrote his Gospel at the very end of his Gospel. You want to know why Luke wrote his Gospel? Just go to the first page. Here's why I'm writing. But if you want to know why John wrote, you actually have to wait until you get to almost the end of the book. And here's what John says. He says, "Now Jesus did many other signs in the presence of his disciples, which are not written in this book." So lots of miracles, lots of signs and wonders. John did not even include them, okay, because not enough space. He says, "But these are written." Why, John? Why did you write about these signs? "So that you may believe. And that by believing, believe that Jesus is the Christ, Son of God, and that by believing you may have life in his name." So think about this for a minute. The whole purpose for John writing his account, writing his gospel, is so that people would read about the evidence and believe and put their faith in Jesus. So the evidence is what he's providing. You know, in John's day, people got to see Jesus perform these things, and they would see and believe. Well, I don't get to see like that, okay? Jesus isn't here in Barrie performing miracles. And so, like that. And so, what do we get? Well, we get something, I actually think, even better. We get to read and believe, okay? And what do I mean by even better? If you read 2 Peter has, in chapter 1, I think Peter's describing, he's describing how he was there on the mountain of transfiguration. And he heard the voice from heaven. And then if you keep reading, Peter says, "But you have something more sure," he says. More sure than even that experience. That you would do well to pay attention to as a lamp shining in a dark place. And then he says, "No prophecy was ever given by the will of man, but men spoke as they were carried along by the Spirit." So he's talking about the scriptures. Yeah, I had this experience. I was there. I heard a voice from heaven. You guys have something even better. What could be better than that? Read your Bible. Okay, that's what he's saying. Read the scriptures. Okay, so this is not against evidence. This is John providing evidence so you would read and believe. Okay? That's not a blind leap in the dark. That's not a blind leap. That's not wishful thinking. So I actually like the word trust better. Faith is trusting in light of the evidence. That's what John's talking about at the end of the first century. Of course, today, it means the opposite. Believing in spite of the evidence. Maybe an illustration will help. Okay? An illustration, here's one. Imagine you're standing at the edge of Niagara Falls. You guys been to Niagara Falls before? Right? It's not too far away, so you got to go there, check it out. And you see this magnificent waterfall. Let's just imagine there's this guy. His name's Charlie Blondin, and he's performing acrobatic tricks at Niagara Falls. Okay? And one of the tricks he's performing is he's walking across a tightrope with a wheelbarrow full of rocks. Okay? And let's say you're there, you're watching him, and he does it once, he does it twice, 3 times, 5 times, 10 times, let's say 15 times in a row. And he sees you watching him, and so he comes over to you, and he says, "Hey, you've been watching me do it now. Do you have faith that I could do it again?" And you say, "Of course I have faith you could do it again. I've seen you do it 15 times in a row." And then he takes the wheelbarrow, dumps the rocks out, and says, "Okay, hop in." That is biblical faith. It's trust. It's commitment. It's like climbing in the wheelbarrow, but it's not blind. It's based off something. It's based off evidence. It's based off evidence. And so, I mean, there's all kinds of illustrations. I trust or have faith in my wife more today than when I married her 15 years ago. Why? Just because I'm like mustering it up as some kind of weird, feeling? No. Because she has given me all kinds of evidence over the last 15 years to trust or put my faith in her. Okay? That's how trust works. It's not a blind leap in the dark. Okay, so that's what faith is. So now you can see, if this is what faith is, it's active trust based on evidence, maybe there is some scientific evidence out there that could actually be compatible with faith and strengthening your faith. Okay? Maybe there's some scientific evidence for God or something like that points to God. Okay, so let's look at science for a minute. Okay, so the first thing I want you to know about science, this is something I didn't know growing up, I guess because I went to a public school. No one ever talked about the fact that all those guys that have units named after them were like Christians. I mean, most of them. I mean, most believed in God, and I would identify most of them as Christians. Although there's some debate over Newton and some others, whether or not like Newton was a Trinitarian or was a Unitarian or something, But for the most part, they had a Christian worldview. In fact, C.S. Lewis, makes this point in his book Miracles. He says, men became scientific because they expected law in nature, and they expected law in nature because they believed in a lawgiver or a legislator, okay? So they were basing the whole enterprise of modern science off of a foundation that was, for the most part, Christian. Well, who are these men of science? There are people like the father of modern science, Francis Bacon. How about Galileo? I know a lot of people think, there's just kind of this myth that goes around that it was Galileo versus Christians or something, versus the church. And that is just not, there's a whole thing I can't get into. Galileo was a Bible-believing Christian, okay? The biggest problem with the Galileo thing was he was challenging Aristotelianism, which is what the church and everybody else held to. And I'm not going to get into all that, but anyways, so there's Galileo. There's Kepler. I was going to say he was also a jerk. Okay, he wrote this book, and he called the guy who played the Pope in the little story was called Simpleton. Okay, like Simplicio. Okay, so that wasn't very nice either. Kepler, the laws of planetary motion that we have. Kepler discovered those. You have Blaise Pascal, Robert Boyle, Sir Isaac Newton, Michael Faraday, Mendel, he was the guy with all the genetic stuff. Louis Pasteur, next time you have a glass of milk, think about him. Lord Kelvin, and then James Clerk Maxwell. These are big name guys. These are the guys who have units named after them. And they were all believers in God, and could be argued that most of them were Christians as well. Actually, there's a book by a guy named Tom Holland. Now, not Spider-Man, okay? This guy's the historian. He wrote a book called Dominion, how the Christian Revolution remade, that's a typo, remade the world, okay? And he says this, without Christianity, we would not have science. That's his claim. By the way, this guy's not a Christian, okay? He considers himself agnostic, although sometimes he wears the label Christian because he believes the Christian worldview has so influenced everything about you. Whether you call yourself a Christian or not, you have been so influenced by it. Brett Kunkel was talking about the water you swim in, right? It's like most people don't even realize we are swimming in the water of the Christian worldview. Now, a lot of that's kind of changing now with some of the stuff happening in the culture, but it's really the foundation of the morality that we have and so on. Christianity. In fact, one of the most popular, most important physicists, next to Einstein or Newton, was probably James Clerk Maxwell. And he had a Latin inscription carved into the doors at the Cavendish Laboratory at Cambridge University. So Cambridge University, one of the most prestigious universities in the world. The Cavendish Laboratory, one of the most prestigious laboratories in the world. And what is written on the doors when you walk in? Magna opera domini exquisita and omnis voluntatis Jesus. Okay. Now, where's the homeschoolers? They know that. I made a similar joke this morning. I don't know, there's so much Latin in my presentations these days. It actually means, great are the works of the Lord, studied by all who delight in them. Psalm 111, verse 2. Think about that. A Bible verse is carved into the doors of one of the most prestigious labs in the world. Kind of neat, right? And yet we're told all scientists should be militant atheists. I don't think Lawrence Krauss has done his homework, right? He hasn't seen where history has where we've been in history. And so a lot of people think belief in God is like a median that is going to block science. You need to be an atheist if you want to do science. Forget this God stuff. But in reality, it's not a median blocking science, it's actually the motor that was driving science from the very beginning, okay? Which is really, really cool. Now, there's going to be an objection that comes up. And it kind of goes like this. It says, look, Tim, you don't understand. Years ago, superstitious people thought that lightning came from the lightning god, and thunder came from the thunder god. But we know better now. You know, science has informed us that lightning is an electrical discharge. It's electrons. And thunder is just rapidly heated, expanded air molecules. They make a noise. Don't need Thor or Zeus. Don't need any gods for that, okay? Science is going to, in the same way, explain all that supernatural stuff. Those explanations are going to decrease, and all the natural explanations are going to increase. And so this is often called the God of the gaps kind of thing, God of the gaps argument. Tim, you're just using the God of the gaps argument. You're saying, I don't know how to explain it, therefore God did it. Lightning? I don't know how that is. God did it. Thunder? I don't know. It's kind of weird. Maybe, you know, yeah, they're bowling up there or something. Okay, that's God. That's the gods. God did it. But over time, those God did it explanations are closing and closing and closing. And eventually we will explain everything naturalistically. That's what a lot of people think. Just give science more time and we'll explain everything naturalistically. Russell Coburn, he says this. He says, understanding science doesn't make God smaller. So this is what they think. As you explain things in science, God gets smaller and smaller. He says it actually allows us to see his creative activities in more detail. As you study, and I'm going to show you this, we're going to look at God's creative detail in a second, okay? And we're going to see that God is not going to get smaller. Your view of God is going to grow, okay? And we'll jump there in just 1 minute. But here's the last thing I want to say about science, okay? This guy right here, Anthony Flew, he passed away a few years ago. But he was probably the most famous philosophical atheist alive in the 21st century, at least when it comes to publishing academic atheist papers. No one beats out Anthony Flew, okay? This guy was arguing, defending atheism for years. In fact, you can go on YouTube and watch him as an atheist arguing against debating Christians. He wrote a book at the end of his life called There Is a God. In fact, the word no is on there, but it's crossed out. There is a God, and the subtitle is How the World's Most Notorious Atheist Changed His Mind. How the world's most notorious atheist. So this was fascinating when it came out, and I thought, I got to read this, and I just want to read you this part of it, okay? Listen to this. He says, I now believe that the universe was brought into existence by an infinite intelligence. That's the origin of the universe. He says, I believe that the universe's intrinsic laws manifest what scientists have called the mind of God. That's the fine-tuning of the universe. I believe that life and reproduction originate in a divine source. That's the origin of life. Those are three different areas of science. And then he says this. Why do I believe this, given that I've expounded and defended atheism for more than half a century? The short answer is this. This is the world picture as I see it that has emerged from modern science. Okay, when someone says, well, it's all God in the gap stuff. I don't know, therefore God. Anthony Flew would not be convinced by an I don't know, therefore God kind of argument. Okay? This guy, you can watch his debates, he would always claim, I'm trying to follow the evidence, I'm trying to follow the evidence. I actually think he did and changed his mind. Now, it's unclear whether he became a Christian. He certainly, he talks a little bit about the resurrection at the end of his book in this book, There Is a God. But it's not clear. But he certainly thought that science points to God, which is kind of neat. So what I want to do is I want to walk you guys through an argument. Now, normally what I do is talk about the origin of the universe at this point. But I talked about that last night. And if you were here last night, I don't want to say something. I want to give you something fresh. So what I'm going to do is I want to talk about the fine-tuning of the universe. Okay? Okay, so let's go to this. Okay. How much time is that? Okay, excellent. Okay, I want to tell you a true story. It all takes place April 11th, 1970 at 2:13 p.m. Eastern Standard Time. Who knows the significance of that date? Or wants to take a guess?
Your birthday.
Just take a guess. Who said my birthday? I'm offended. It's the hair thing. I was born in 1983. So you put, I'm turning 40 this year. You just put me over 50. Not cool. Okay, who wants to give a better guess than that?
Your parents met.
My parents met. No, they met even before then.
And then Star Wars came out?
That's a good guess. That's a good guess because the font, right? It always does that. Not Star Wars either. Actually, it was. I heard Apollo. Someone said it. It was the launch of the Apollo 13 spacecraft. Now, this was the third scheduled mission to land on the moon. And if you know the story, they'd never land on the moon, right? You see, everything was going to plan on this magnificently designed spacecraft. However, 55 hours and 54 minutes into the mission, traveling at 2,000 miles per hour, the crew hears and experiences an explosion. And then you get Captain Jack Swigger's famous words. You guys know it? Houston?
We have a problem.
We have a problem. And they had a big problem. If you know the story, one of their oxygen tanks had exploded. And the second's like leaking in space. They're now losing cabin heat, shortage of electrical power. I mean, everything that could possibly go wrong is going wrong, and then some. Like they practice and simulate and all this stuff, possible scenarios, and this was just a scenario that they thought was impossible. And yet there they are, floating in space. The three astronauts had a new mission, and that was to get home safely. And if you know the story, they did. 6 days later, right? Apollo 13 would land on April 17th. And this mission was called a successful failure. A successful failure. Now, why am I telling you about that? Well, just as the Apollo 13 crew survived against all odds in the lethal conditions of space, we too survived against all odds on this tiny planet we call Earth. Okay? The conditions to make the astronauts able to survive in space, it's finely tuned. And the slightest change in those conditions puts the lives of the astronauts in jeopardy. The slightest change in the conditions of the Earth, the solar system, the galaxy, the universe, puts our lives in jeopardy. In fact, they talk about it as if it's balanced on a razor's edge. Think of a tightrope walker across two skyscrapers. Literally, on either side of the tightrope, it does not support life. You guys know what I'm talking about? Like you take one step to the left or one step to the right, you're dead. Only the narrow position on the tightrope allows for life to survive. In the same way, what I want to do is show you that Earth and our solar system and our galaxy and even our universe in general is finely tuned to support life. Okay? Now, there's so many of these things that I could talk about, so I'm just going to pick and choose some as we go here. I might skip some because I want to make sure you guys. But again, we're going to show that God is not small, God is big as we go here. Now, the first thing, you guys are probably familiar with Goldilocks and the Three Bears, right? Or it's too hot, too cold, just right, right? Well, there's something in the solar system that's called the Goldilocks principle. And essentially the Goldilocks principle says that where we reside in our solar system is at just the right distance for our planetary star, which we call the sun. Pretty good. And yeah, there we are, third rock from the sun. Now, what would happen if we were to kind of change our location? Well, so we're in the Goldilocks zone, the Goldilocks principle here. If you were to go a little bit further out from the sun, it's too cold, okay? If you go a little bit closer, and by the way, Mars is out there, Mars gets pretty cold. At its equator in the summertime, average temperatures are like 0. When you get too close, well, it gets too hot, okay? For example, Venus. Venus is like 700 degrees Fahrenheit. Now, it has a runaway greenhouse effect because of all the carbon dioxide, but so that changes the game too. Too hot though for life. Where we are is just the right temperature, but it's not just about temperature. It's the temperature to get liquid water. That's what really matters. If you have no liquid water, you have no life, okay? And so if you go too far out, ice, You go too close, you might get water vapor. But we're in like this Goldilocks zone that allows for all three states of water, solid, liquid, and gas. Actually, what you're looking at is kind of a miracle there. Let's just kind of zoom in and talk about this for a second. So water is really neat. So we're in the Goldilocks zone to get liquid water. But water in itself seems to be finely tuned, okay? Or at least special. But what I mean by that is, okay, our Earth is 70% covered in water. Water has a very high specific heat capacity. What that means is it can hold a lot of energy before it raises its temperature. You guys know this when you like are maybe you like on the driveway, you're washing the car, and if you were barefoot, your feet are like boiling because like the asphalt is just totally hot because it doesn't take much to raise the temperature. But you could have a little puddle of water and you could just cool your feet down because that same energy won't raise the temperature as quickly. But what you're looking at, so all that's cool about water, but what you're looking at is the coolest thing because that giant ice cube is floating, right? Now, why aren't you guys impressed by that? So I want you to think about this. Every known substance, every known natural occurring substance that we have come across, when it goes from its liquid form to its solid form, does it get more dense or less dense? From liquid to solid?
More dense.
More dense. This is particle theory. You learned this, probably in this classroom, And the particles get close together, more dense. And more dense means sink, not float, okay? What's going on with this thing? Well, water is the only substance where when it goes from liquid to solid, because of its molecular structure, H2O, it actually gets less dense. And it's why that thing is floating. In fact, if water was like every other substance, then lakes and oceans would freeze from the bottom up because ice would just keep dropping and collecting as you go. So this would be a real problem for life, making it highly improbable, if not impossible, okay? So water is really, really cool. And in fact, if you have any water, you could just, get it out right now. You can taste the fine tuning. I just wanted to drink. So that's just one example, but there's all kinds of examples. Like, let me just, again, I want to get to the really fun stuff, so just bear with me. I'm going to hammer through some of these. You know our Earth is tilted? You probably felt it when you walked in the room. You don't feel it. It is tilted, though. If it wasn't, the equator would be a lot harder and the poles would be a lot colder, okay? But because of its tilt, we actually get at 23.5 degrees. It actually kind of regulates the temperature. Now, the tilt is sustained by our large moon. Most scientists think that if we didn't have our moon, human life would be impossible, okay? But what stabilizes our tilt at 23.5 degrees is a moon that is a quarter the size of the Earth. Really, really cool. And, we can say more stuff about the moon. But the tilt is kind of neat. The magnetic field. Our sun, although it keeps us warm and allows for liquid water, it also is bombarding us with all kinds of deadly cosmic radiation and deadly cosmic particles. Here's the thing. They actually get deflected by this kind of giant bar magnet in the center of the Earth. Our liquid iron core acts like a magnet. Produces these field lines, and so it deflects the particles to the poles, which actually interact with the atmosphere, and we call it the northern lights, right? So every time you see the northern lights, just know that that's like keeping us alive, all right? But I can see you guys totally are not impressed by any of that. So let's look at the next one. So if we go from the Earth, you probably know that we are just one of many planets in our solar system. Do you guys hear what happened to Pluto?
Dwarf.
Got demoted. It's a dwarf planet. So sad. Now, do you know why it got demoted? What do you think?
Its gravitational force was enough to clear all the objects out of its orbit.
Yeah, so it doesn't have its own orbit. See, a lot of people say it's too small, whatever. But because its orbit crosses over with Neptune, it hasn't cleared its own orbit, it's not considered a planet. Like, I don't know who gets to make that call, right? But because it crossed over Neptune's orbit, it actually is not considered a planet, it's a dwarf planet. So let's get rid of it. It's still out there, but we're just getting rid of it for now. So we got the 4 gas giants and the 4 terrestrial planets that are close up. What's really interesting is when we look at other suns out there, other stars, most of the big gas giants are super close to the sun, to the star, which would not work for us. These guys actually act like the offensive line. I don't know if I can use football analogies here in Canada, you guys, but you know the really big guys, right? The really big guys, the offensive line, the guy that snaps the ball, he's protecting the quarterback, right? And these guys are protecting us, the quarterback. In fact, here comes an asteroid, and everyone together. Oh no, it's an asteroid heading straight for us. Wow, I believed it. A little Armageddon situation here, Bruce. And but we're not worried about that. Why? Because Jupiter acts like a cosmic vacuum cleaner, sucking up all kinds of space junk. In fact, that's not me. When I was teaching at the public school, 12, 13, and teaching through some science, they in their solar system unit, they actually said that Jupiter is a cosmic vacuum cleaner, and said if Jupiter didn't exist, you wouldn't either. And it's true, because we think that Jupiter gets hit like 5 times a month by massive objects that could annihilate life on this planet. Okay? There's actually, like, Jupiter as it orbits the sun, there's all this stuff that orbits behind it because its gravitational pull is so strong. This is not to scale. You can actually fit 1,300 Earths inside Jupiter. This is a storm right here. It's the red spot on Jupiter. It's like 2 times the size of the Earth. It's a hurricane, 2 times the size of the Earth. So it's cool. Like, quite honestly, we should thank God for Jupiter and the other gas giants. If they didn't exist, we wouldn't either. My daughter, when she was like 3 or 4, my oldest, she's now 11, was in like the back of the room when I was giving a presentation like this, and she heard it. So that night, she's like, "Dad, I want to thank God for Jupiter." So we did, and like for a year, and in her prayers, every time I was like, "Thank you for Mommy and Daddy and her sisters, and for Jupiter." There you go. Tonight, that'll be your prayer. We go into our galaxy. Again, our galaxy's cool. This is not a picture of our galaxy because we're in it. It's hard to take a picture of the galaxy you're in. But we think it's a spiral galaxy like this with a black hole in the center. It seems like, by the way, it's 100,000 light years across. So if you're going to measure a galaxy, your meter stick is not going to cut it, okay? And so how far does light go in 1 year, which is like 6 trillion miles or 10 trillion kilometers? 100,000 light years across. I think there's 100 billion stars in the galaxy, which, I mean, I don't know who counted or how they know that, but that's the best estimate. We are between spiral arms, which is where life can exist, okay? And you don't want to be too close to the center of the galaxy or too far out, okay? Not a lot of heavy elements out here, so think you're a periodic table of elements. There's some things that life needs, like carbon and oxygen and some of these other things. So you want to be in an area that has those. And there's a lot of super giant stars here, and when those blow up, we call them supernova, and you don't want to be next to one. Okay? I mean, like, seriously. So it seems like there's a Goldilocks thing happening even where we live in our galaxy. But I want you to forget everything I just told you. And you're probably thinking, already done. What you're talking about. The real fine-tuning has to do with the constants and the quantities that are literally kind of put in at the beginning of creation. Like, for example, the strength of gravity. Where's the dial going to be for gravity when you make the universe? How fast is the speed of light going to be? All these things. If you start messing with these dials, you end up completely changing the universe and destroying any chance of life. And I'm not talking about like no life. I'm talking about like no stars, no planets, no chemistry. Sometimes there's just a few particles floating around, okay? So think of like the dial set right now at life permitting, and we change the dial, and it goes from life permitting to life prohibiting. You cannot have life. So fine tuning, it's like when you have a dial. You guys remember tuning dials? Did anyone still tune a dial, you know? When you had to do that. Now we just hit the button on our phone or whatever, but you used to have to kind of find the radio signal and then it'd come in, right? Here's what the scientists who are not Christians are saying about the fine tuning. So here's Freeman Dyson. He says, the more I examine the universe and study the details of its architecture, the more evidence I find that the universe in some sense must have known we were coming. Huh, that's a strange thing to say, right? When you're not a believer. Fred Hoyle, he was a hardcore atheist. He probably changed his mind at the end of his life. And it was partly because of the science. He says the common sense interpretation of the facts suggests that a super intellect has monkeyed with physics as well as chemistry and biology, and there are no blind forces we're speaking about in nature. The numbers one calculates from the facts seems to me so overwhelming as to put this conclusion almost beyond question. Here's George Greenstein. He says, as we survey all the evidence, remember we're talking about evidence here, the thought insistently arises that some supernatural agency, or rather, he puts capital A agency, must be involved. Was it possible that suddenly, without intending to, we've stumbled upon scientific proof for the existence of God? The answer is yes. Was it God who stepped in and so providentially crafted the cosmos for our benefit? The answer is yes. Look, if you're going to make a cake, you're going to get instructions, right? And if you start messing with the instructions, you change the cake. And there might be some flexibility when you're changing the instructions, but let's say like you take out the flour, you change the flour from 2.5 cups to 5 cups. Or if you got rid of the eggs completely. Or if you take the temperature from 800, from 350 to like 800, you're going to change your cake, right? Well, this is the job, by the way, of theoretical physicists. What they do is they're looking at the universe and they can say, well, what would happen if, in like kind of in theory, what would happen if we change this? And let's run a model and see what happens to the universe. And this is what some of these guys are doing. And what they're finding is, you mess with some of these instructions, these details, you end up destroying life. So for example, you probably didn't wake up this morning and think about any of the particles that are making up everything in the universe, okay? But there are certain fundamental particles that make up everything. It used to be, we used to think, electrons, protons, and neutrons make up everything. Well, it turns out, and there you got your periodic table, right? And hopefully no one's like triggered right now. Okay, it's been a few years since you were in a chemistry class. And so helium has 2 protons, 2 neutrons, and 2 electrons. There's our helium atom. Okay. Well, they smash particles together in these colliders. And it's really cool stuff. And what they found is neutrons and protons are actually made up of other particles. They call them the up quark and the down quark. So 2 up quarks, I don't know who named them. Okay, kind of lame names. But 2 up quarks and a down makes a proton. 1 up and 2 down make a neutron. And then the electron, we can't seem to break that anymore. Okay? And so it's fundamental. Here are the masses of those 3 particles that make up everything. All visible matter is made up of these 3 particles, and these are the masses. Now, typically they're not in kilograms, but we all know what a kilogram is, okay? These are very small numbers. In fact, there's a lot of zeros, okay? And so you're not getting out your bathroom scale and measuring a proton or an electron, okay? But these masses are very, very small. Now, here's the question some theoretical physicists were asking. What happens if we change these masses? What happens to the universe? Does it really matter how much an electron weighs, really? Well, if you change the down quark just by a factor of 3, let's just multiply it by 3. It's still a very small number. What happens to your universe? Remember chemistry? Gone. You have a universe of only hydrogen. If you change the up quark, which maybe you didn't even know existed until 3 minutes ago, by a factor of 3, the universe is destroyed, okay? How about the up quark? Change it by a factor of 6, increase, and it's even worse. You don't even get any chemistry, like you get no hydrogen. All you have is neutrons floating around, just neutrons. Protons become unstable. No protons, just neutrons. And then finally, the electrons by 2.5, you end up, that's your neutron universe. This is a life-prohibiting universe. There is no possible life in this universe that is not, like, maybe immaterial life, like you could have angels, okay, but not the kind of life that we're thinking of, like material life. Okay, so those were like the amounts of things like protons and neutrons and electrons, that kind of deal. What about fundamental forces? Okay, let's talk about gravity, because I know you understand gravity is what's keeping your bums in the seat, okay? Now, I actually so gravity basically says that every two objects in the universe are gravitationally attracted to each other. So, I'm attracted to my water bottle right now. You could calculate that gravitational attraction. I am attracted to the Andromeda galaxy 2.5 million light years away right now. So are you. And this is actually a pickup line I used on my wife. Before she was on my wife. So we're in the science library. I told you, I was going to circle back to this. We get introduced to each other, okay, because we had some common friends. And so I get introduced, she's very beautiful, and I say to her, you know you're attracted to me. Now, I had hair back then. So it was a different thing. And she said, excuse me, like, who do you think you are? And I said, well, gravitational. It's a physical attraction. Now, I know that sounds lame, but she married me. So, gravity. We're attracted, every two objects in the universe are attracted to each other. Here's the equation I would teach you if you took my physics class. That value, we think, this constant, this big G, is finely tuned, we think, to 1 part and at least 10 to the 40th power. That's a 1 followed by 40 zeros, okay? Now, what do I mean? Like, the chance of you getting struck by lightning are like 1 in a million. The odds of you, like, winning the lottery in Canada are 1 in 100 million, okay? The odds of you being struck by lightning, surviving, and then being struck by lightning a second time in your lifetime are 1 in a trillion. But the odds of getting a life-permitting gravitational constant is this whole thing. Okay, here's like a quick illustration to help drive this home. Imagine we take the continent of North America, the whole continent of North America, and we cover it in dimes. Say, that's a lot of dimes. It is a lot of dimes. I copied and pasted all those on. That took me a while, okay, for you all just to look at that. Okay, now, we are going to stack those dimes all the way to the moon. All right, I want you to say, that's a lot of dimes. Thank you. In fact, I gave up. I just did this right. Okay. Now we do that on 1 billion more continents the size of North America. Now that is a lot of dimes. 1 billion continents all the way to the moon. And then I take one of those dimes and I paint it red. And I'm going to call this the life-permitting dime. And I throw it into the sea of dimes. And then Andrew here, my friend, I blindfold him and I put a gun to his head. And I say, pick the red one or you're dead. All right, it's a life-permitting dime. Now, if he picked the red dime, I think everyone in the room would say, Andrew, you peaked, right? You designed the outcome. Because even though it's the same odds of getting any dime, it is vastly more probable that you would pick a non-red dime than the single red dime, okay? And so this should give us a clue that there's something more going on here. But someone might say, Tim, there's still a chance, right? There's still a chance. And that reminds me of a famous clip from a movie where Lloyd Christmas meets Mary at the beginning of the movie. He falls in love with her, not love at first sight. And then the whole movie, he's trying to reunite with Mary. And then he reveals his love. And he asks her what his chances are of them being together. And here's the aftermath.
What are my chances?
Not good.
You mean not good, like 1 out of 100?
I'd say more like 1 out of 1 million.
So you're telling me there's a chance?
Yeah! All right. So when we say 1 part in 10 to the 40th power, we're not saying there's a chance, okay? I mean, there's a chance, but we're saying there's no chance. And by the way, gravity's easy to talk about because you guys know what gravity is, okay? The cosmological constant, which is almost like a reverse gravity, like an anti-gravity, it's what's actually blowing everything apart. It's actually fine-tuned, they think, to 1 part in 10 to the 120th power. Now, these numbers get so ridiculous, okay? Because there are only, we think, 10 to the 80th power of particles in the universe. Particles in the universe. So when you start talking about these numbers, I know we can put zeros on a slide, but our minds cannot fully comprehend any of this, okay? You just can't. And so this is why they were saying, man, it's almost like the universe knew we were coming, right? Robert Jastrow, he's a famous astronomer, and he wrote a book called God and the Astronomers. He says, and he was agnostic, by the way, personally, but he says, for the scientist who has lived by his faith in the power of reason, the story ends like a bad dream. He has scaled the mountains of ignorance. He's about to conquer the highest peak. As he pulls himself over the final rock, he is greeted by a band of theologians who have been sitting there for centuries. Because what have they been saying for centuries? In the beginning, God created the heavens and the earth. Right? In the beginning, God created the heavens and the earth. And this is what we are beginning to just scratch the surface of in the 20th century. What I know, we're getting close to the end of the thing here. There's so much I want to say to you guys. But what I'm going to do is I want to take the question. We looked at faith. Faith is not a blind leap in the dark. Faith is active trust based on evidence. Science, from its very inception, is not opposed to God. In fact, it was belief in God, an orderly creator who made the universe. When they started the universe, they were doing an act of worship. Okay? It was science that gave birth or it was the Christian worldview that gave birth to science. And then, of course, there's some science that actually points to God. And so when you bring those two things together, and we ask the question, are science and faith compatible? The answer is yeah, of course. Of course they're compatible. And it's really just a shame that most people haven't heard any of this stuff. I know when I was in university, I didn't know any of this. And it took years and years and years of reading and studying to actually fleshing this out. And that's why one of the things that gets me out of bed in the morning, especially talking to young people like we did last night, over 500 young people here, is to tell them that you don't have to check your brain at the door when you become a Christian. And you can be in love with science, and you can follow in the footsteps of James Clerk Maxwell and some of these other famous scientists, and love God and love his creation and doing science. So hopefully we've just started to scratch the surface on that, and that's more clear in your minds. But I'm wondering if you guys have any questions. Yes, sir.
What do you think about the idea that without faith, logic and reasoning and scientific survey?
Without faith, I don't know if they would be circular. I know some people have tried to argue that you need God to have logic. And that might be true. We ground things like morality in God, right? His very nature. So you have, so where is the moral law? Well, God gives the law through his commands, but ultimately goodness is grounded in God, we think. Some have argued that logic itself, the law of non-contradiction, the law of identity, some of these laws that we all work from, whether we know about them or not, we all use them when we're thinking. And that itself could be grounded in God as well. So to deny that, well, you've kind of undermined the very foundation. Just like you undermine your foundation for morality when you get rid of God, you undermine your foundation for logic and maybe even science itself. So it's possible. I haven't been totally convinced on that personally, but I just haven't looked into it deep enough either. Good question. Anyone else? Yes, sir.
And what's the latest thinking on the Big Bang Theory and how it relates to God creating the world?
Yeah. So typically, when it comes to, because I know Christians, we will disagree on the age of the earth and this kind of thing. But when I'm talking with an atheist, and they believe in the Big Bang, I have an argument for God right there. A Big Bang means a Big Banger, essentially. Or because what the Big Bang says is, like the standard model at least, says the universe had a beginning. That's why the Big Bang was so controversial when it first came out. It wasn't actually the Christians who were attacking it, it was the atheists. Because all of a sudden, you couldn't have an eternal uncaused universe anymore. You had a beginning, and a beginning points to a beginner. And that's why you have some of these, like Sir Arthur Eddington and some of these other scientists saying, the thought of a Big Bang is repugnant to me. I quoted Fred Hoyle. Fred Hoyle, he hated the Big Bang. He's the one who came up with the name, the Big Bang. Oh, you just believe in it, Big Bang. And it was kind of like this derogatory term that ended up sticking, right? But Fred Hoyle, he came up with his own idea called the steady state theory. The steady state theory tried to keep the universe eternal. And there aren't, I don't think, many people that would hold to a steady state theory today. Because the arguments for an origin to the universe are powerful. The expansion of the universe, we now know the universe is expanding. And not like slowing down, so it's going to crunch back in and do like some kind of yo-yo deal, like an oscillating model. But it's actually accelerating in how it expands. Like think of gravity. I drop my water bottle, it actually picks up speed as it falls. The universe is like picking up speed as it expands, which is really, really wild to think about. But if you go back, the universe is smaller, and you end up getting to a beginning point of the universe, a beginning point to time and space. And if you have no time and space, you have nowhere to put anything, right? No matter, no energy. Well, what could cause time, space, matter, and energy to come into existence? Well, the cause must be timeless, spaceless, immaterial, and extremely powerful. What does that sound like? And that's why a lot of people have really pushed back against the Big Bang. The Big Bang is not an atheist argument, okay? It is a theist argument. Now, it may not be a Christian theist argument, depending on your view of Genesis, okay? That you may have issue with that. Okay, that's something we can talk about in-house, right? But I'm not, so that's where I would go. I think the Big Bang is an argument for God, not against God. Yep.
So with your knowledge in apologetics, how do you find it impacts your witness? Like, do you bring it up in most cases when you're witnessing, or do you more resort back to your personal story?
No, what I would do, I don't ever bring it up. It ends up coming up. You can't do evangelism. Well, that's strong. It's hard to do evangelism in the 21st century and not end up talking about apologetic issues. It's like if I was outside with a backpack and I had a loaf of bread in it, okay? And I'm trying to feed people as they come out. Who wants a piece of bread? The first question you're going to ask is, where's that bread from, right? What's in it? Who made it? You have a whole bunch of questions before you take and eat, okay? And I think it's similar when it comes to the gospel. We share the gospel. Let me tell you about Jesus. And people are like, wait a second, Jesus in that book that's full of contradictions? That Jesus? You mean, what? I thought that guy was a myth. I thought Jesus was a myth. So now you're answering these kind of questions. The guy who said he identified as God, well, I don't believe in God. Okay, let's talk about that, So now I'm talking about whether the Bible's reliable, I'm talking about the existence of God, I might be talking about evidence for the resurrection, I may be talking about... So the conversation ends up going to these apologetic issues. So I'm not bringing it up. I'd love to just talk to you about Jesus. There was one time in my life where I shared the gospel with someone, they received the gospel, and they had no apologetic questions for me. One time, and that was my grandfather. And he was dying. And that changed your perspective. Like, I'm near the end of my life. I'm looking for a lifeline. Yeah, that sounds pretty good to me. I'll take that. I'll take, someone who takes away my sins, kind of deal. Otherwise, you're talking to people at university campus. No, they want to put up a fight. They got questions. And so, that's how you spell evangelism. You spell it, A-P-O-L, apologetics.
Like, I guess tactfulness would be important as far as like where you're coming from, because by nature you want to win the debate, right?
Yeah.
There's more than that, obviously. As far
Of
as
course. So that is the difference between kind of what people think about apologetics, and I get why they think about it the way they do, because there are some apologists who give apologetics a really bad name. Like, I'm just going to fight with you.
Right.
Our approach is stand to reason. Look, here's something you all need to read immediately. It's the book Tactics. There's a book called Tactics, and it, for me, changed my life. The Bible changed my life, like, in one way. When I read the book Tactics, it changed how I talk to people. So my now boss, he's the one who wrote it. But when I was doing presentations on tactics, like I was teaching people how to do tactics, because I read the book and I was like, I need to tell everyone about this. And then I got hired by them because they saw I was already teaching the material. So they're like, you should just work for us. But the approach is knowledge, wisdom, character. You got to know some stuff, but you don't have to know everything. Wisdom, that's tactical approach. And then character. We want to be ambassadors, right? And so I could win the argument, but lose the war kind of thing, right? Because at the end of the day, they don't want, I've turned them off Christianity. So my goal is not to win the argument. My goal is to put a stone in their shoe. That's my goal. I want you walking away annoyed, but in a good way. Because I gave you something to think about, right? So, and that's a totally different mindset. And so the tactical approach is using questions. That's what Jesus did. Read your Gospels, you'll see that Jesus asked more questions than he answered. Why is the wisest, smartest man who ever lived asking more questions than he answered? Because that's the approach. You want to get people to think about God and think about themselves and their worldview and all those other things, use questions. I tell you what to believe. Believe in God. Why? Because I says your back's already against the wall, right? But if I say, hey, I'm curious, like, where do you think the universe came from?
Right.
Or, do you believe in morality, good, right and wrong, evil? You could point to any evil. That shooting, that was wrong, right? So where do you ground your morality? How do you determine what's right and wrong? And now I'm kind of working my way through questions to like an objective standard. Again, questions are just like disarming, and they're friendly, and they show I'm interested, because I am interested, When I met my wife, one of the first things we did, she invited me to for her birthday to go bowling. So now I'm with all of her friends, and it's me, and there might have been one other guy I knew. But I'm sitting next to this other guy, we're talking, I'm asking question after question, because I was reading Tactics. Question after question after question. And by the end of the evening, so everyone went home, this guy calls my wife and says, that Tim guy is one of the most interesting people I've ever met. He didn't know anything about me. I spent the whole night asking him questions. The whole night. But there's something about people who show an interest that we like. And Jesus showed interest in people. You should too. So Tactics, I'm telling you, email them. You buy the book, read it, don't just put it on your shelf. Actually read it, then send me an email. And I guarantee you will say, Tim, where has this been my whole life? Why wasn't this taught to me in Sunday school?
That's really cool.
So it's the way we should do apologetics. Okay. I got to close this out because you guys have a break in the session coming up. So I'll hang out here for a little bit. You got questions? You want to chat? I can do that, but I don't want to hold you up. Thank you for coming. Hopefully you guys learned something and go and give them heaven with this stuff. All right.
Thank you so much, Tim, for the incredibly encouraging and helpful message and teaching today. And I think we can all leave with some more tools in our toolkit, and to be encouraged that science is not at odds with faith, and that we can walk confidently knowing that God has created our world with order and with purpose, and we can discover that and rejoice in Him and praise Him. So. Maybe just love to pray with us really quickly.
Oh, sure.
And then we'll kind of give some instructions for the next step. Father, we thank you that you are God of heaven and earth. We thank you that you have created and made and sustain all things, and all things have been made through you and for you. We thank you that we can know you, that you are not too big and not too far off for us to draw near to you through your Son Jesus. We thank you that you uncover our eyes, God, that we're able to see you and to walk with you and to enjoy you. And we pray that as we leave this place, that we would be able to see the wonder and the awe and the intentionality of your design, and that we would be strengthened in faith, and that we would be able to communicate some of these things that we've learned today, and that you'd help us to do that in a winsome way, in a loving way, and that ultimately you would be glorified through that. So we give you the rest of this afternoon, and we thank you for this time together in Jesus' name. Amen.